I'm excited to be here today with Nick Coubray, CEO of Howick from New Zealand. Hi, Nick. How are you?
Hi, man. Great to be here with you.
We will talk today about the latest and greatest in prefab and the cold formed steel framing technologies and how it's empowering offsite construction with the use of BIM to CNC and how that would really have a positive impact on affordable housing and sustainability and other challenges we have in the industry. Can you tell us about your company and your vision at Howick and the work you've been doing in New Zealand and in other regions?
Yeah, so Howick is a third-generation family business based out of Auckland, New Zealand, in the suburb of Howick, which used to be a little village in its own right. And we used to build all sorts of things. So we started off building just general engineering machinery for all sorts of people, for making ice cream, for making enclosures for whiteware like fridges and things like that for the local industry. And out of that grew quite an innovative team, so we could make all sorts of different things. And then we sort of turned our eye to looking for a product, and construction seemed to be a good fit. So we built the first framing machine probably 30 years ago now, and from that it's grown from a very simple machine to quite a complex machine, and the industry has changed. It's something we always thought 30 years ago that within 5 to 10 years this will be everywhere. We're getting to that point now. It's starting to hit the tipping point. We've got customers who build everything from garden sheds right up to 10 to 15-story buildings that are fully cold-formed structural buildings. So there's a huge amount going on in the industry.
Can you tell me more about how the prefabrication market in New Zealand looks like right now and how it's evolved in the last 10 years?
Yeah, so it's growing a lot now, driven a lot by labour shortages and the cost of building. So traditionally, we've been very traditional sort of small builders. Now there's a lot more bigger contractors out there that are starting to embrace things like bathroom pods, like prefabricated frames brought to site. There's a lot of what we call cabins, which are kind of like a tiny home. There's a large number of companies making those, which are all prefabricated now. A mixture of steel and timber and some concrete construction as well. So it's quite a wide, diverse sort of industry here at the moment. There's a lot going on, but it's still quite new to most people.
You're obviously one of the best manufacturer of high-precision machinery to support the prefab. How is this high-precision machinery process and equipment is been helping to transform our EEC industry? And how is that making a difference from 10 years ago?
So it's really interesting how it's working now because the accuracy actually allows you to do different things. So you have this really accurate structure that you're starting with. So if we start with an accurate foundation, which is always a bit of a challenge, but we get that right, then the frame is accurate on it, and then everything down the line is also accurate. So you get all these gains, not from the actual framing itself, because if you look at the framing, the cost between a timber frame and a steel frame is fairly comparable as a material price, but it's those benefits you get. So we have one customer who pre-orders all their carpet pre-cut. They pre-order all their stone benches cut to size because they know the room will be within a quarter of an inch accurate at the worst. So all of that comes off the timeline. So where that traditionally would be, we finish the structure, then someone comes and site measures, they can order it and say, deliver it on this date, we'll be ready, and it goes straight in. So all of a sudden you start saving 3 and 5 days here and there. So the project can be shortened up hugely. That's the biggest benefit of the accuracy that comes with it. And then, of course, you can start pulling material out as well, because if you accurately know how strong the studs are and where they're placed and how they're connected together, we can do some quite clever engineering things to reduce the impact of the building.
You bring up a great point about precision. How about, there's a misconception in the industry that prefab and modular construction has to be boxes and uniform structures. How is your technology empowering architects to design more flexible geometries?
That's kind of a historical thing. The square boxes was, early days, square boxes were easy to draw and the software wasn't really there to do anything in a more clever way than a box, because most of it was done to, I think, back 10, 15 years. We were designing single 2D panels and then assembling them in a 3D box. Now there's all sorts of interesting things that can happen with the software.
We've just done a project in Auckland for one of the big law firms, and it's got 39 different curved walls in it with different radiuses in their office, where they couldn't do that before, or it was manual and someone had to go and mark everything out. We made the panels as a flat panel and then formed them on site into the right shape and put them up in the building. Now it's quite an interesting one because there's no straight walls in the whole building, so I'm not sure where they're going to put the desks, but it's just showed what could be done with one of the big architecture firms, and now that they've seen it, they can apply it to other things.
So how is prefab and steel framing and modular offsite construction in general, from your experience, having a saying in the project delivery method?
It's really compressing that timeline. So, for instance, when we talk about our telescopic stud, sort of briefly, and other things, and that allows us to make panels that are adjustable. And we've actually found through that process that 80 to 90% of the panels can actually be made the same. Now, there's a little bit more waste in the material inside the panel itself, but because we can pre-make them, we know that that can be delivered to site as and when required. It can also be made early, and then we can come back and look at just those final few panels.
And how the telescopic stud works? It's a simple but very powerful idea.
Yeah.
How did you came up with this idea, and what is the best use for it? Can you tell us an example of a project in New Zealand that really benefited from that technique?
We're working on some projects in New Zealand now where we've done a hotel, which is 16 floors, and we pulled between 50 to 70% of the labour for man hours for the installation out for the framing piece, which is huge, obviously. So you're pulling a lot of people that you just don't have on off-site. So the big benefit for those guys was that once we got the process working well, it went really fast. And again, it was mainly rinse and repeat because it was a hotel, so most floors were the same. We then did something for the bulkheads where you have a concrete floor with concrete bulkheads in it for the fire protection. So they were doing it traditional timber on site, so cutting pieces of timber and hammering them together and putting them into the space. That was taking them 7 days per floor. We reduced that down to 2 days per floor. So you can see the massive saving there from a little bit of design thinking further ahead. And if you look at stud and track builders, they are getting better, but historically they've been 30% waste because all the bundles of stud come to site and then they get chopped up and stuff gets thrown in the bin or stuff gets taken back off site. But they're never really that accurate. Some of them are doing cut to length now, but you still have that adjustment piece. You still have to factor in how am I going to make it fit, and safety.
Field teams don't have to go cut each piece, which increase safety, which is a first priority for any construction site.
Exactly, and even working at height's a great place for the telescopic panels. We've done some ceiling panels and soffit panels and things, so they can go up in the scissor lift with the panel and adjust it in situ to fit, where traditionally they'd have to go up and measure, make the panel, take it up, and if it didn't fit, bring it back down, process it again and put it back up. So those savings are really hard to measure and they're hard to quantify. So when you're sort of QSing a job, how do you measure that? You only know it from doing it.
And how is this supporting sustainability initiatives and CO2 emissions reduction efforts?
Yeah, so there's a number of things happening in that space. Obviously, the steel is recyclable, which is great. If it goes back to the mill and can be recycled. There's a lot of green steel mills starting to come online and in the near future that will be coming online. So those are great sort of things by themselves. The other things we look at, like the telescopic studs, for instance, you take the stuff to site, you're only taking the material that you need. It's in the panel already. So you're not having extra material that you're cutting and throwing away. You're not having extra material that you have to pick up and remove from the site to go to either recycling or landfill. So the material itself is, again, a bit like I was talking about the accuracy. It just allows these knock-ons that are quite hard to measure. So if you imagine a traditional building, say you're doing 10,000 square feet and there's 30% waste of steel stud from a traditional build, that has to be picked up, so it's another truck movement somewhere out and back. It's more raw steel that was produced in the first place. That's where we see the big knock-on effects. The other one is taking mass out of the building. So we have, with the steel stud, if we design it right, we can pull the foundations down a bit, so you take more concrete out of the foundations.
What's your advice for folks who are starting their journey with prefab and cold-formed steel?
Yeah, it's really important to talk to people. So come to some of the conferences and things and talk to people about what they're doing. We find most of our customers are reasonably open. They're not really competing with each other because we're still a small part of the market. The off-site construction is maybe 3 to 5% of the market. It's not huge yet. And most people are happy to share, especially through our network of customers all over the world. So if you're doing something in the US, the customers in the UK are quite happy to talk to you because you're not standing on each other's toes and you can share ideas, and there's lots of amazing things that can
One of the many ways we can learn from each other is really sharing ideas even within the same market.
Yeah.
Because our whole goal is to push our industry forward.